Hello, students. I'm Pallavi, your maths instructor, and today we'll start a new chapter from your book Ganita Manjari, grade 9, maths. This chapter is chapter 6, measuring space, perimeter, and area. So, this is the first part of this series where we'll be starting with understanding what exactly a perimeter means. So, what exactly is a perimeter? What exactly is a perimeter? So, I'll just explain by making a diagram here. So, this is a rounded one, but this is a rectangle. Maybe, yeah, this is now a rectangle, right? So, now suppose this is here, it is a looking like a rectangle, but just assume this is a park in your society, and this is you. Okay, this is you. I'm making your hands and legs. Okay. Okay. So you start from this point A, which is this corner, right? And then you go around this park, reach this corner, come to this part, then take again a turn, and then again go back here. You reach the starting point, which was A. So when the total distance that you covered when you started from point A, went around and reached back to the starting point, that is the perimeter. So this is the perimeter of this rectangle. Similarly, it can be any other shape. For example, I can make a triangle here. Right? This is a triangle. Same. You start from this point A here, and then you go this way, then this way, then this way along the boundary and reach the starting point back. So this entire distance that you traveled, that is the perimeter of the triangle. Okay. So in the earlier grades, you have already learned, right? For example, if you have a square here and this square, the square is of side A, right? So what I mean is this, yeah. So this distance so this is one side of the square. This length is A. So if you think about it, the way I was telling here, you go around this square, you will cover this side A distance, this side again A distance, this side again A distance, and this side again A distance. So that makes perimeter of the square equal to 4A. Now in the same way, if you see, if we have a equilateral triangle. So equilateral triangle, I hope you all remember, it's the one which has all these three sides of equal length. So here, this length again, I'll say this length is A. Each side is of length A. So what will happen if you start at this point and start moving from one end of the triangle, and you start moving around it. So this part will be of length A, then you will travel a distance A. Here again you will travel a distance A, here again you will travel a distance A. So what will be the perimeter of the equilateral triangle? You covered the distance A 3 times, so it will be 3A. Similarly, we'll take a rectangle. Now, in square, all sides were equal. In equilateral triangle, all sides were equal. But in rectangle, we know already, right? The sides are not equal. So what we assume here is our length is A. The length of this rectangle is A. And the width of the rectangle is B. We'll draw this so that you're clear. This is B. So if I'm starting from this point, how much distance will I travel? First, I'll travel A, then I take a turn, I'll travel the distance B, then again here I'll take a turn, so I'll travel the distance C, sorry, again A, right? This distance is A, and then I take a turn here and travel again the distance B. So ultimately, how much distance am I traveling? 2 times A plus 2 times B. That makes it 2 times A plus B. So basically, it is twice of length plus breadth. So we can say here, perimeter of a rectangle with length A and width B is equal to 2 times A plus B. So these things you have also studied in your lower grades and you're already familiar with that, right? So now what about a circle, right? What about circle? We have seen all these shapes which had straight lines, but the circle has curved line. So it will not be exactly same as what we have been doing here. So to find out that, long back, our mathematicians, they tried to explore this, right? What will be the perimeter of a circle? So they started finding out about the relation between the side and the perimeter. So for example, they started with a square. Suppose this square has side of 1 unit, right? So this has side 1 unit. What will be the perimeter? It will be, I told right now, 4 of the side. So it will be 4 units, right? Now, what they did was they doubled its size. Now its side was 2, right? So the side is 2 units. So perimeter will be 4 into 2, which is 8 units. So when you see here, the ratio between perimeter to side. So here the ratio is perimeter to side is 4:1. Here if you see, perimeter to side ratio. This is 8:2. And if you simplify it, it will become 4:1. So the conclusion is for square, the perimeter to side ratio is equal to 4:1. Then what they did was they tried the same thing with a circle. Sorry, with a equilateral triangle. So what they did was they took an equilateral triangle of 1 unit. Each side was 1 unit. So this is equilateral triangle. Side 1 unit. So what will perimeter be? 3 into side. So it becomes 3 units. Now what they did was they increased the length of its side. So now the same equilateral triangle, they made it of 2 units. So side is 2 units. Then perimeter became 3 into 2 is equal to 6 units. Right? So now what is the perimeter to side ratio here? It was 3:1. What is the perimeter to side ratio in this case? It is 6:2. And if you simplify it, it becomes 3:1. Right? So you see, as the length of the side increases, there is a change in the perimeter. For square, the perimeter increases 4 times. Every time the size changes by 1 unit, the perimeter changes by 4 units. Similarly, for equilateral triangle, every time the side changes by 1 unit, so initially it is 1 unit, the perimeter is 3 units, side changed by 1 unit, so change in perimeter is again 3 units are added, right? 1 unit is added to the side, so 3 units are added to the perimeter, so that it becomes 6. So there is always a ratio of 3:1 in case of equilateral triangle. So then they thought the same way we can observe for a a circle, what happens, right? So in case of circle, what is the perimeter? Again, you start from this point, right? You start from this point and then you just go around and around and you again reach back at point A. This becomes our perimeter of the circle. But in this case, in the case of circle, perimeter of the circle is called circumference. Okay. So now here they wanted to find the relation between the circle's circumference, and circle doesn't have a side. What does it have? It has a radius or diameter, right? So they started finding the relationship between the circumference and the diameter of the circle. So now what they started doing, okay, they took the diameter 1 unit. Okay, diameter was 1 unit. They found the circumference of the circle, right? We don't know at this point what was that. Similarly, then what they did was they made a circle of 2 units and then they found the circumference of the circle. Now what they started doing was they started seeing the ratio here. Okay, they started comparing the ratio just like they did in the earlier shapes, right? So the circumference to diameter ratio for this particular circle, how much is it? Then for this particular circle, what is the circumference to diameter ratio? And when they continued with circles of different sizes, with the different diameters, they were able to find out that this ratio is also a constant. And what is the value of this ratio of circumference to diameter is a constant called, they gave it the name pi. Okay. So this is the pi. This is the symbol of pi. Okay. So that is where they discovered that this ratio is always equal to one constant, which is the pi. Okay. And then they found out that the circumference of the circle is actually pi d. So I can't make the symbol again and again. So I'll just write it as pi. Okay. So this is pi into d. Or if we make the symbol, it will be pi d. So C is equal to circumference. Circumference is equal to pi into d. Now, what is the value of pi? They also had to find out the value of pi, right? So now there is a lot of history behind how so many different mathematicians tried out different methods to find out what exactly is the value of pi. Okay, so they found a lot of different values, and finally they came to the conclusion that the value of pi is approximately 3.14. Actually, it just continues. It is not exactly equal to. That is why I said it is approximately equal to 3.14 or 22/7. And when I'm saying this is actually a approximation, this is not the exact value. This is the approximation that is done. Actually, this pi is a irrational number. And irrational numbers, they just keep on going and going. I mean, they are non-repeating and non-recurring, right? So they can't be represented by a fraction actually. So that is the reason this 22/7 is a approximation. So this actually goes on and on. It's non-repeating and non-terminating and non-repeating. Irrational number. Non-terminating, non-repeating, or non-recurring, you can say. Okay. Now, there was an interesting fact when you see this 314, right? So in US, when they write the date format, what they do write is month and then date, right? So given that, if you see 3/14, this is March 14th, and they started calling it Pi Day. They started celebrating it as Pi Day. And the other one, it is 22/7, but this is in term of date and month. So this becomes 22nd July, and 22 by 7 is not the exact value of pi, right? It is a approximation of pi. So it started getting called as pi approximation day. So this is just some fun facts, and there is whatever, like, the history is behind the finding out the value of pi, the different methods the different mathematicians took. All that you can just read in your Ganita Manjari book, chapter 6. That's a very interesting read, and you'll really enjoy it. Okay, so now we come to the topic of circumference. So already I told circumference of circle is pi into d, or you can even write it as small d. Okay, so I'll draw a circle here so that we are able to see things clearly. Okay, so this is our circle, and this is the diameter. This is the center. Okay, so diameter, we know already, right? What is the diameter? Diameter is equal to twice of radius, 2 into r. So if we have to write circumference of the circle in terms of the radius, then we'll write pi into 2r, or it becomes 2 pi r, or you can also say how it is written is, if we put the symbol of pi, this is 2 pi r. Okay, right. So this circumference, this is the distance covered when we start from one point of the circle and return back to the same circle after covering the entire boundary of the circle, right? Now, what if we take only the semicircle? So when we are going around the semicircle, then we are covering half of the distance, right? So this means the circumference of a semicircle will be half of the circumference of the circle, right? So this means will be half of 2 pi r. Now this 2 and this 2, it's because 2 divided, it becomes 2 divided by 2. So it's 1. So ultimately we are left with pi into r. So circumference of the semicircle is pi into r. Now what about if we see the quarter of a circle, right? So if we take quarter of a circle, this means the circumference will be 1/4. Quarter is 1/4 of the total circle. So it will be 1/4 of circumference. This means it will be 1/4 into 2 pi r, which means it will be It is 2 divided by 4, which will be 1 by 2 of pi to r, right? So this is half of pi r by 2. Okay, so if we start seeing it in a different light in terms of angles, right? So semicircle, what is the angle which semicircle subtends at the center? Semicircle makes a straight line. This is the diameter. It's a straight line. So it is subtending an angle of 180 degrees. So what is the angle subtended by a full circle? Full circle is this complete. So this angle, this complete angle is 360 degree, right? Semicircle, half of this. So this is making 180 degree at the center. What about a quarter of a circle? Now this quarter of the circle is this much. This means it is half of semicircle. Semicircle is making 180 degrees. This is making 90 degree. So this is making 90 degrees, right? So if we start, writing it all together, full circle, 360 degrees, circumference is equal to 2 pi r, semicircle 180 degrees, c is equal to 2 pi r by 2, which is equal to pi r. Now similarly, quarter circle 90 degrees, circumference is equal to 2 pi r by 4, which is equal to pi r by 2, right? So with this, what we are observing? What we observe is, this is actually, we can say that it is circumference of full circle, which is 2 pi r into 180 by 360. This 180 by 360 is 1 by 2. 2 by 2 is 1, and then it becomes pi r. Similarly, here, this is the circumference of the full circle, 2 pi r, and then we are multiplying it by 180 degrees, the angle subtended by the semicircle, upon 360 degree, the angle subtended by the full circle. So if we see, it is more like a unitary method. Now, full circle, 2 pi r, 360 degrees. So if we have to calculate how much is the circumference for 180 degrees, it becomes 2 pi r upon 360 into 180. Similarly, here you have full circle, circumference is 2 into pi into r, and we multiply it by, what is the angle subtended by quarter circle? It subtends 90 degrees. What is the angle subtended by full one? That is 360 degrees. So 90 upon 360 is 1 by 4. 2 pi r by 4 will be pi r by 2. This is the same what we found here. So if we generalize this now, for example, we have this circle and we just take this arc. And this arc, this is the center O. Okay, and make this, can assume it is angle theta. So this particular arc is making angle theta at the center. This arc AB is making angle theta at the center. So for any arc making angle theta at the center, we can generalize what will be the circumference of that arc from this, whatever we have seen until now for semicircle and quarter circle. So for an arc making angle theta at the center, circumference of the arc will be what we had seen. We had seen we take it, the full, whatever is the circumference of the full circle into the angle made by the arc upon the 360 degree. So this will become 2 pi r, which is the circumference of the full circle, into the angle theta. This is the angle theta. I think it was better if I just wrote the word theta, because the way I drew it was really pathetic. Yeah, so this is better. Okay, and upon 360. So this is the formula for calculating the circumference of the arc. 60 degree. This. Okay, so this is the circumference of an arc, any arc which subtends an angle theta at the center. Now there are some interesting examples in your book which we can go through. So here I have copied this diagram from your book. So this is the figure 6.12, and what we have been given is that these two are circles, two circles. So this must be example 6.1 in the book. I'll just check. Yeah, this is under 6.5. It is example 1. Okay, so what we have been given here is these are two circles. two circles of the same radius. Okay? They have same radius and they are passing through each other's center. So one circle is, at the has the center A. The second circle has the center B, right? Now this circle, right hand circle, is passing through the center of the left hand circle. Left hand circle is passing through the center of the right hand circle. And they both are intersecting at the points C and D. Okay, so each circle passes through center of the other. Okay. That is the second thing. Then circles intersect at C and D. Okay. So now what we are asked is we need to find out. So we need to find out what is the perimeter of the red portion of what we have been shown here in this diagram. Okay, so this is between C to D, both sides. Okay, so when we see this, we are able to make out immediately, right, that if we have to find out the perimeter of the circle, only the red portion of the circle, this means we are excluding the part between C to D on both sides. We need to exclude this CAD and we need to exclude CBD. Finding out the total circumference, if we have to, for the whole circle A is easy. For example, if we see only first circle A, so circumference of circle A, circumference will be 2 pi r, right? Circle B, circumference will be 2 pi r. Total will be 4 pi r. Simple. But here we are not given that simple thing. What we have been asked is ignore the overlapping part. So then how do we do it? What we'll do is we will draw a triangle. So first we'll join A to B. Okay. So this A to B, A to B is the radius of circle with center A. Similarly, if we see B to A, it is the radius of the circle with center B, right? Now I join C to A. Now C to A, what is the length? Again, it is the radius of circle with center A. I'll join A to D. Again, radius of the circle with center center A. Now let's see circle B. For circle B, I'll join B to C. Now both these circles have same radius. So A to B is a common radius anyway. It's a common radius for both circle with center A and circle with center B. Now B to C, when we join, it is again the radius for the circle with center B, and we join B to D. Again, it is a radius of the circle with center B. Okay, so this, let me put this. So this is R. It's not very Good. I'll use this color. Okay, so this is, if we are assuming it is, both circles have radius r, so this will be r, then this will be r, CB, AC is r, CB is r, and r, AB is r. What else is r? A to D is also r, and D to B is also r. So if we consider the two triangle ACB, it is an equilateral triangle of side R. Triangle ACB is a equilateral triangle of side R. Okay, and similarly, triangle ABD, or in the same way if we write, it becomes ADB, is an equilateral triangle of side R. So we know the property of equilateral triangle. What is the property for equilateral triangle? For equilateral triangle, all angles are equal. Each angle is how much? The sum of all three angles is 180 degree. All angles are equal. So 180 by 3, which is 60 degrees. So when we come to know the angle, then what we can look at here? So what we look at here is this angle. What is this angle? This is 60 degrees. And similarly, what is this angle? This is also 60 degrees. 60. 60. So now let's see what we learned about the circumference of arc. Because for an arc which makes an angle theta, at the center, the circumference of the arc is 2 pi r into theta by 360 degree. So going back by that, we will see this arc CB. This arc CB is making an angle of 60 degree at the center, right? So then the circumference okay, so before that I'll write these two are equilateral triangles. So every angle of triangle ACB and triangle ADB are of measure 60 degrees, right? Now this arc CB is subtending an angle of 60 degree at the center. Subtending angle of 60 degrees at the center. So what this means? Circumference of arc CB. Now here, yeah, this is arc CB, BD, AD, and AC, right? So circumference of arc CB will be 2 pi r into 60 by 360. What is this? What is 60 by 360? 60 by 360 is 1 by 6. So this will become 1 by 6 of 2 pi r. Now similarly, just like we found for arc CB, we can find it for arc BD. Or maybe we can do it together. See this entire arc, now rather than individually, we can see the entire arc CBD, right? Because it is subtending, we know this is 60 degree, CAB is 60 degree, BAD is 60 degree. So together it is making 120 degree. So rather than finding out for individually CB and BD, we can directly find out for CBD. The arc CBD is subtending an angle of 120 degrees at the center. So I'll say this CBD, or maybe I'll break it down so that we'll understand CB and then BD. So I'll copy this. So this will be arc BD. Okay. And then what is this arc CBD? So arc CBD is subtending an angle of 120 degrees at the center. So how do I remove this? And this. I don't know how to remove this. So let's just forget it. So we'll say the arc, circumference of arc CBD, this is 60 plus 60 is equal to 120 degree, the center. So circumference of CBD will be 2 pi r into, now what is it subtending? 120 degree. So it will be 120 by 360. So then it will become equal to 120 upon 360 is 1 by 3. So it will become 1 by 3 of 2 pi r. Right? It's 1 by 3 of 2 pi r. So now what we found is CBD is 1/3 of the circumference. 2 pi r is the circumference of the circle. So CBD is 1/3 of this circumference. Similarly, for circle B also, we can find out that CAD is 1/3 of the circumference of the circle, right? So now we have to exclude. So, okay. So now if CBD makes 1/3 of the circumference, then this other side, bigger side CD, the highlighted portion CD, how much will it make? That is the 2 by 3, right? So when we learned fractions, we learned it, right? That if, we are dividing, we are making, we are dividing a slice of pizza into 3, and we are taking one slice, then how many slices are remaining? It's 2. So similarly, this part of the circumference, which is 1/3 of the total, we are removing that. So we are left with the circumference, which is the 2/3. 2/3 of the full circumference. So this is the highlighted red part of what circle? Center A with center A. This is equal to 2/3 of the full circumference, which means, and similarly, we'll see highlighted red part of circle with center B will also be the same. It will be 2/3 of the full circumference. So when we add the highlighted portion of circle with center A and highlighted portion of circle with center B, what do we get? So we'll say that perimeter of highlighted red portion, it will be 2/3 plus 2/3, or maybe we can write just this way, circle of the full circumference. So then it will be 2/3 of 2/r. Or you simplify it, then it becomes 4/3 pi r. Similarly, this becomes this is also the same. The highlighted red part of circle with center B will be 2/3 of the full circumference, which means it will be 4/3 pi r. So the sum, if we do a sum of both these portions, we will get the perimeter of the highlighted portion. So then it is going to be 4/3 of pi r plus 4/3 of pi r, which means this is 8/3 of pi r. Okay, so it was fun doing this, right? Did you enjoy doing this example? I will write this pi and make this symbol, and this is r. 8/3 pi r. That is the answer. So this is done. Let's do the second example. So this is the diagram given for the second example. Okay, I'll write it as example 2. So what we have been given here is the length of this arc PQ is A. Okay, so this means this circumference of this arc PQ is A. Is equal to A. And this PQ basically, they have also told that this is a semicircle. Okay, so arc AP, sorry, why did I write AP? This is PQ. PQ. So circumference of PQ, arc PQ is A, and also this arc PQ is a semicircle. Similarly, this arc, there isn't a name provided here. Maybe I will add some name to it. So PQ is already taken. I'll put it A and I'll call it this one as B. Okay. So now PA is also a semicircle. Okay. So arc PA is also a semicircle. So they are all semicircles of different radii. Okay, so PQ has a bigger diameter, PA has a smaller diameter. Again, AB has a small diameter which is even smaller than PA. And maybe, I don't know, this BQ, whether it is, it looks slightly bigger. So, but I don't know, it has not been given, what's the size of each. So we just know that they are all semicircles. Okay? And we also have been given the circumferences. Circumference of arc PA is B. And then I'll just copy it. And I'll just, okay. So PA is done. Now AB. So arc AB is also a semicircle. And the circumference of arc AB is C. Similarly, the last part, BQ. So arc BQ is also a semicircle and the circumference of arc BQ is D. Okay, so this is what we have been given. Now the question is actually, they are asking the distance between P and Q, which is this length A, whether it is greater, because there are two paths of going from P to Q. This is a point P, this is the point Q. So there are two ways of going from point A to point Q, point P to point Q. One is through this route, taking this arc A. The second one is the roundabout way, going this way, right? So now the question here is, which way is longer? Is A greater than B plus C plus D? Or is A smaller than B plus C plus D? Or both paths are of equal distance, which means, is A equal to B plus C plus D? So this is what we need to find out. Okay? To find out, is A greater than B plus C plus D, or is A less than B plus C plus D? Or the third case, is A equal to B plus C plus D? So to find out that, what we'll do is, let me remove this. Oh my God, remove the entire thing. Huh? Okay, so I just want to remove this, and I just want to remove this. So I just wanted to clean up the figure. So now what we'll do is, I'll just draw a line so that we get more clarity, right? So now we drew a line from P to Q, so it is clearly visible that this part is a semicircle. And AP is also a semicircle, AB is also a semicircle, and BQ is also a semicircle. Now, let's take an assumption that, let's take an assumption, this is green, right? So I'll take blue. So what I'll say is, this radius, okay, so this is the radius of the circle, this PQ1. Okay, so I'll call this A dash, or maybe let me use a darker color, A dash. Okay, and similarly, what I'll do is, suppose this is the center, and I'll make the radius for this here. So this radius is, we can call it B dash. Okay, and similarly for circle C, we'll take the center and we'll draw the radius. So we don't know actually what is exactly the radius. That is why we are just assuming, we are calling it in that way, that okay, this is A dash, this is B dash, this is C dash, and the last one we'll call it D dash. First let's draw the radius, and then we'll call it D dash. D dash. Okay, so now we learned about the circumference of the semicircle. So what was the circumference of the semicircle? Circumference of semicircle is pi r, right? So for our PQ, yeah, so we can say, we are told that its length is A. We can say this A is equal to pi of A dash. Similarly, B is equal to pi of B dash. Pi into radius, this is the circumference of a semicircle. And we have been given the length of the arcs. So that is why we know C is equal to pi of C dash, and D is equal to pi of D dash, right? So if we are taking, for this second half of the circle, this PQ is the diameter, right? So if we are taking one side is A and the other side is BCD. So when we are summing B plus C plus D, this is actually pi B dash plus pi c dash plus pi d dash, or we can write it as pi of d dash plus c dash plus d dash, right? Now b dash is the radius, c dash is the radius, and d dash are the radius. So if you see here, this entire thing, this will be the twice of b dash. This thing is twice of c dash, because this is again the diameter, right? We have been already told this, these are semicircle, and this is twice of d dash, right? So that entire length PQ is twice of b dash plus twice of c dash plus twice of d dash. And what is this entire length PQ? This is also, this radius is the bigger one, radius is a dash, right? So this is the semicircle's diameter. This will be twice of a dash. So we can write it as PQ is equal to twice of b dash plus twice of c dash plus twice of d dash is equal to twice of a dash. This diameter plus this diameter plus this diameter, right? So that is what is 2b dash plus 2c dash plus 2d dash. And that is, this PQ is the diameter of the circle with arc A. So that is 2a dash is the radius. So the length of PQ is 2a dash, right? So this will mean that we take 2 out from both the sides. This will make it as a dash is equal to b dash plus c dash plus d dash, right? So what we are seeing is the radius, this radius of the bigger semicircle is equal to the sum of radius of the 3 semicircles. And we also saw that b plus c plus d is equal to pi of b dash plus c dash plus d dash. I didn't write here. I should write for a also. So a is also the circumference of the semicircle. So this is going to be pi of a dash, right? So what we can write is a by pi. A dash will be a by pi. So we can write it as a, maybe I'll write it as 1 by pi of a is equal to, how did this come? See, a is equal to pi into a dash. So a dash will be a upon pi. So this is what we are saying. A upon pi will be, similarly, we can do it for b dash, c dash and d dash, right? We know here, we have written here, right? So we'll write here 1 by pi. So this will be, I'll say b by pi. B by pi plus c by pi plus d by pi, right? Now this 1 by pi, if we take out common from both the sides, will be 1 by pi into A is equal to 1 by pi B plus C plus D, right? So then what we can say, we can, 1 by pi is common on both the sides, so we can easily remove it. B plus C plus D. So what does this mean? This arc A, length of arc A is equal to the sum of the length of arc B, C and D. So here the answer is 3. Both the paths, whether we follow this route from P to Q, or we take the roundabout route from P to Q. We will be traveling equal distance in both the cases. Even though when you just look at the figure, definitely it looks like, the second one, the roundabout one is longer, right? But when you calculate it, they both are of the same length. So A is equal to B plus C plus D. This is the answer. So our answer is this third one. Okay, so with this, we are done with the first part of this chapter, and you can go ahead and attempt the problems in exercise 6.1. And I'll meet you in the second part of the video on this chapter next. So till then, bye-bye.